We've done addition, subtraction, multiplication. Maybe the one thing that we're missing here is how to find a quotient of two complex numbers, how to divide one complex number by another. And to get there, we first want to talk about reciprocals. What are reciprocal? What is a reciprocal? The reciprocal of a complex number z is defined as the number 1 over z, or z to the minus 1, equivalent notation, such that z times 1 over z is equal to 1. So take your original complex number. What number do you multiply it by to get 1? This is the reciprocal. And so as it turns out, there's a very, 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 very elegant formula for the reciprocals for the reciprocal of a complex number. And so in order to figure out what it is, let's go back to this formula from the previous video. So z times the conjugate of z gives us the modulus of z squared. And remember that this right here is a real number. Okay, so what I'm going to do is I'm going to divide both sides of this equation by the real number modulus of z squared. By the way, I really should make it clear here that obviously there's no reciprocal of 0, so we want to exclude that. So we're assuming that we have a non-zero number here. So what I'm going to do, I'm going to divide both sides of this by the real number, the modulus of z squared. So that's 1 over modulus of z squared times z times the conjugate of z is equal to 1. And now using associative properties and stuff like that here, I'm going to rewrite this as z times 1 over the modulus of z squared times z conjugate is equal to 1. So 1 over the modulus z squared, that's a 1 over a real number. That's a real number because the modulus is not 0 here. So we're doing a real number times the conjugate of z. So this is a well-defined thing right here. And this is going to be what our reciprocal is. So formally, what we have is if z is equal to x plus iy, 1 over z is equal to 1 over the modulus of z squared times x minus iy. Let me write that. Let me write that as the conjugate of z. And now using x's and y's, it's 1 over the square root of x squared plus y squared times x minus iy. There's the conjugate. Sometimes I just might write as x minus iy divided by the square root of x squared plus y squared. So this is our formula for the reciprocal of a complex number. It might seem like this would be a difficult thing to figure out, but it's really not. Let's just do a couple examples of this. So for example, if we were to have z is equal to 1 minus I. So what would we do here? Well, so we need the modulus and the conjugate. So this kind of combines the two ideas from the last video together very nicely. The modulus of z would be the square root of 1 squared plus minus 1 squared is square root 2. And the conjugate of z would be 1 plus I. And so putting that together, we see that 1 over z is going to be 1 plus I divided by the modulus squared. And of course, that would be 1 plus I divided by square root of 2 squared is 2. Let's check that. I think it's good for us to check it, that z times 1 over z here. We know we need to get 1. So it's going to be 1 minus I times 1 plus I divided by 2. So multiplying together, I'm just going to move the 1/2 out in front. So 1 times 1 is 1, minus I, and then plus I. Those will cancel. And minus I times plus I is plus 1. So we are left with those cancel, 1/2 times 1 plus 1. Sure enough, we get 1. So that checks out. That 1 plus I divided by 2 is the reciprocal of 1 minus I. Another useful example here, and I think maybe this kind of shows just how cool complex number conjugates and reciprocals are. Let's say that z is equal to, let me say minus 1/2 plus square root 3 over 2I. And again, we're going to find 1 over z here. So how do we do that? Well, once again, we need the conjugate, and we need the modulus here. So the conjugate, okay, this should be unsurprising here, minus 1/2 minus root 3 over 2I. And then the modulus here is going to be the square root of minus 1/2 squared plus square root 3 over 2 squared. So minus 1/2 squared is 1/4. Root 3 over 2, quantity squared is 3/4. 1/4 plus 3/4 are 1. Square root of 1 is 1. So this has modulus 1. So our complex conjugate, sorry, our reciprocal is going to be 1 over 1 squared times the complex conjugate, minus 1/2 minus square root 3 over 2I. And so what is going on here? This is just the conjugate. So if the modulus of z is equal to 1, which is an important special class of complex numbers, then 1 over z is equal to the conjugate. The reciprocal and the conjugate are the same if the absolute value, sorry, the modulus of z is equal to 1. So that's pretty cool. That's pretty cool. And I said we see some geometric stuff about the reciprocal, sorry, about the modulus and conjugate. I said we'd see that in a future video. We'll also see some geometric interpretations of this in a future video as well. Okay, so to finish off this video, we have to talk about quotients. So if we want to do z1 divided by z2, we literally define z1 divided by z2 to be z1 times the reciprocal of z2. So in some philosophical sense, you know, you don't really need to do division, you just multiply by reciprocals. So, you know, how do you do 35 divided by 7? Well, that's real, you know, it's in some philosophical sense, you're not really dividing by 7. You're finding the multiplicative inverse of 7, which is 1/7, and then multiplying, you know, 35 by the multiplicative inverse of 1/7. And so that's how we're going to define it. So don't worry, don't think about what does it mean to divide one complex number by a number. Don't get bogged down in those details. Just say, I need to find the reciprocal of the denominator complex number, and then I need to multiply those two together. So let's just do a quick example of this. So for example, if I were to ask you, what is 2 minus 6i divided by 1 minus I. Well, let's go back here. It's going to be 2 minus 6I times 1 over 1 minus I. And I think I did this right. Yeah, this is one we already found the reciprocal of. So 1 plus I divided by 2. Okay, so then putting all of this together is just a straightforward multiplication. 2 times 1 is 2, minus 6I plus 2I minus 6I times I will give us plus 6. And so our final answer is going to be 1/2 times 2 plus 6 is 8, minus 6 plus 2 is minus 4I. And so that looks like we end up with 4 minus 2I. So that is how you divide one complex number by another.